Hello everyone. In this lecture, we will discuss the applied partial differential equations. If you recall the previous article, we have studied the Fourier series. Now we use the Fourier series technique to solve the one-dimensional wave equation and one-dimensional heat equation, and which are basically the partial differential equations. So before discussing the details of the solution, we will first see the basic things which are necessary to study this partial differential equations. Suppose you are given a function y is equal to fx. So you have only one independent variable and one dependent variable here. So now we can find dy by dx is my f dash x, or I denote it y dash, or I denote it y dot, whatever it may be, right? Now any differential equation, suppose a differential equation here dy by dx is equal to 0, or x dy plus y dx is equal to 0, or suppose d square y by dx square plus 3 dy by dx is equal to 5. So these are all ODE. These are all ordinary differential equation, right? Now if instead of here y is equal to fx, suppose you are given u is equal to suppose here function of x and y, then what will happen? Now here x and y, there are two dependent variable here, and u is the independent variable here. So here if I ask what is del u by del x, you may write it u of x. So at this moment here y is equal to constant. If I ask what is ui, here it is del u by del y, and here it is x is equal to constant, means the other variables are constant. If I ask you what is uxx, means it is del square u by del x square. Twice we will differentiate it partially. Similarly, instead, if u is given a function of xyz, more than two independent variables may also be there. We may define a PDE, suppose uxx plus uyy plus uzz is equal to 0. We may have a PDE ux plus uy is equal to x plus y into u. This is a PDE. So these are the partial differential equations. So basically, for a partial differential equations, we need two or more independent variables we need, but we have one dependent variable. But the dependent variable is 1, right? But the unknown function is 1, right? The dependent variable is 1. In that way, we define the partial differential equations. Now coming to some standard partial differential equations. Now coming to some standard PDE, we will see one-dimensional wave equation. Here utt is equal to c square uxx, right? And one-dimensional heat equation is ut is equal to c square uxx. Two-dimensional wave equation will be accordingly utt is c square uxx plus uyy, right? Similarly, two-dimensional heat equation will be ut is equal to c square uxx plus uyy. Similarly, two-dimensional Poisson equation is uxx plus uyy is some function of xy. It is a non-homogeneous when fxy is not equal to 0. Then two-dimensional Laplace equation is uxx plus uyy is equal to 0. And here three-dimensional, similarly uxx plus uyy plus uzz is equal to 0. So here this can also be written as, we may also write it, del square u by del t square is del square u by del x square. Now this c here, the c is a positive constant. And the c is called the propagation constant, right? Propagation constant. So gradually we will see the solution of such differential equations. So let us now know some basic facts to solve the PDE. If I say what is d by dx of constant, you will say it is here 0. So now the moment I say what is integration of 0 dx is here k. So derivative of k is 0. The reverse, the integration of 0 is here k. Likewise, if I ask you del by del x of some 5y square plus some 7y plus 8. This is also 0. Now this is nothing but a function of y, is not it? It is a function of y, right? It is a function of y. Or I can write it is some c of y, constant involving y, right? So now the moment I say what is integration of 0 del x, means here it is integration of 0 del x is k. So here this k must involve a function of y, as we see here, because y is a constant while we integrate or differentiate partially with respect to x, or I may write it ky. Okay, so this is what it is different. Similarly, if I ask you what is integration of some c1x del x, if I ask, so c1x is, if I integrate sin x, is minus cos x. Similarly, a function of x is integrated to give a function of x, other function of x, but there is a constant here, so that constant will involve the other variables. Suppose u is a function of xy, so this will involve the other variable is y, right? But if I ask what is integration of e to the power x dx, it is e to the power x plus simply a constant here, right? The moment I ask e to the power x del x, means I will say e to the power x is my e to the power x, right? And the constant will involve the other variable if it is a function of 2 variables. If it is a function of 3 variables, then this will involve the other variables too, right? So these basic things. Similarly, if I ask you, suppose I ask you integration of c1x del y. Now the moment I am integrating with respect to y, so this c1x is constant, I can take out c1x, and the integration of del y, so this is my y c1x. Now plus the constant will involve, right? Since we are integrating with respect to y, the constant will involve the other variable if it is a function of x and y. If z is there, then the constant will involve the other variable also of z, right? So now let us use this basic concept to solve some simple differential equations. Suppose you are asked to solve ux is equal to 0, means I will solve it. Here del u by del x is equal to 0, so that means here del u is 0 del x. Now you integrate it, so this implies here u will be a constant involve the other variable, right? But here if I solve, so it is my del by del y of ux is equal to 0, so that means my del ux is my 0 del y. Now if I integrate, this implies my ux will be c1x, because the variable is y here, other variable will be in the constant, so again my del u will be c1x del x now. So now I integrate it here, so my u will be equal to c1x is integrated to give you c2x plus the constant, suppose c3, it involved the other variable is y. So this is the solution here. Okay, suppose I ask to solve uxy is equal to ui, means here del by del x of ui is equal to ui. You may substitute some ui is equal to p, say, right? So accordingly or directly you may write it del ui or del p by then bring it to this side is ui is equal to your del x, right? Now del y is ui is my p, say, so it is del p by p is my ln p, means ln ui is my x plus some constant here is ln c1y, right? So that means my ln ui by c1y is your x, right? So this implies here ui by c1y, so the ln it will be here e to the power x now. Clear? So what is your ui? Ui will be c1y e to the power x. Again here ui will be del u by del y, so del u will be c1y e to the power x del y. So now if you integrate it with respect to y, it is here u, and here it is constant here. c1y is integrated to give some e to the power x is taken out, it is some c2y plus this constant will involve the other variable, right? So this will be your answer. Then suppose one more equation is asked, solve simultaneously. You solve these three simultaneously. So you first start from this. So let uxy is equal to 0. So that means del by del y of ux is equal to 0. So that means your del ux is equal to 0 del y. So integrate both sides. Ux is equal to c1x. Now again you integrate here. So that means your del u will be c1x del x, right? Now again you integrate both sides here. So that means your u is equal to some c2x plus constant c3 will involve opposite variable. Now you see here, this c2x will be addressed from this, right? C2x will be addressed from this, and this c3y will be addressed from this. You see, since uxx is equal to 0, if I write some u is equal to ax plus b plus some phi y, then what will happen? Means x term and y term. So then obviously uxx is 0, then obviously uxx is 0. So since uxx is 0, this c2x will be a term like this. Similarly, here the y term will be, if I write u is equal to some cy plus d plus some psi x, then obviously uyy is 0, is not it? So the y term here must be of first degree, right? Since second derivative is 0 here, so u must be a function of first degree. So I write it. So that means my u is equal to c2x will be something ax plus b plus c3y will be something cy plus d. Okay, so now if I add them, so this will be your ax plus by and some b plus d will be your some k. In that way you will able to solve the simultaneous equation. Now let us see some more problems on separation of variables which cannot be done directly. If I ask you solve ux is equal to uy, then your del u by del x is equal to del u by del y, then how to move it, right? Now you have to apply some trick here. Means what you have to do, let u is equal to f of x into g of y, right? Now what is your ux is f dot x, or derivative of fx, gy remains silent, is not it? And what is uy? Fx remains silent and it is derivative of y, is not it? So now you substitute this thing over here in equation 1. Now 1 follows here f dot x gy is equal to fx g dash y. So now you separate them, right? So that means you bring this and you bring this to that side. So f dot x by fx will be here g dash y by gy, is not it? So now this ratio is equal to this ratio. Can you not say that this is a constant, say, right? Since this ratio is that ratio, so now I individually consider one by one and solve. So if I consider f dot x by f of x is equal to k, then, and if I integrate both sides, integrating both sides, what you will get? Left side is of the form derivative of by f, so it is ln fx, and right hand side is here k, and you see here it is k dx. Okay, k dx means it is kx plus a constant. So that means you see, now you need to add some constant here, is not it? That means we are integrating this side and we are integrating this side with respect to x here. So it is ln fx is this. Clear? Or if you may write it, I may write it ln c1 to get a better answer. So that means my ln f of x by c1 is here kx. So that means f of x by c1 is, it is here e to the power kx. So this implies your f of x is c1 e to the power kx. Likewise, if I consider this g dash y g dash y by gy is equal to your k. If I integrate with respect to y here, then that means ln gy is equal to ky plus some c2. You see here it is ordinary, so this constant is a pure constant only, or I write it some ln c2. Then similarly, what will be my gy? My gy will be c2 e to the power ky. Okay, so now we multiply this together because our u is fx into gy. So we combine these two. So therefore here u is equal to, or u is a function of xy, it is c1 into c2 e to the power kx into e to the power ky. So c1 and c2 will give you another constant, say a, and it is e to the power k into x plus y. So here the direct separation is not possible. You apply this product form, u is equal to fx into gy. Likewise, if I ask you one more problem, suppose uxx plus 9y is equal to 0, 9u is equal to 0. Okay, so now if you recall the ordinary differential equation, y double dash plus 9y is equal to 0. What is the auxiliary equation? Lambda square plus 9 is equal to 0. So lambda will be here plus and minus 3i. So y is equal to c1 cos 3x plus c2 sin 3x. Likewise here you put u is equal to fx into gy and separate the variable in that way. So here u will be, right, it is a function of x, so the constant, it is c1 cos 3x plus c2 sin 3x, but here the constant will involve the other variable. Okay, and if you work out it in details of this way, then you will get this is the answer. So this is the product approach to solve the variable separation technique in solving the basic PDE. Suppose you are asked to solve another problem, ux plus uy is equal to x plus y into u. So likewise, let u is equal to fx into gy. Accordingly, here you find ux is your f dot x gy, and your uy is your fx into g dash y. Now you substitute all this thing here. So here one follows, it is fx g dash y f dot x gy plus fx g dash y is equal to x plus y fx into gy. Now you divide it throughout. So that means here f dot x by fx plus, here if you divide it, fx cancelled, g dash y by gy, and it will be your x plus y. How to separate them? You bring x over here and this to right hand side. So that means here f dot x by fx minus x is your y minus g dash y by gy. Now this ratio is equal to this, you say it k, and you separate them in this way and solve. Okay, so this is the idea. For some short question point of view, you are asked, for what value of c the following satisfy one dimensional wave equation. One question is this. So this implies, what is your ux? Ux is derivative of sine is cos 8 cos 8x, and cos 2x is just a minute, one must be t, it is cos 2t, remain silent. Then here uxx is derivative of cos is minus sine, again 8 multiplied, minus 8 square sine 8x, and your cos 2t remain silent. Similarly, what is your ut? Derivative of cos 2t is minus 2 sine, this is silent, 2 cos 8x, it is sine 2t. Again you differentiate, utt is derivative of sine, again cos is minus 2 square, cos 8x remains silent here, cos, you see. So for uxx, this cos 2t remains silent, and for ut, the sine remains silent. Okay, so you just simply find the partial derivative. Now if you compare them, utt is equal to c square uxx. You see this side and this side, you see here, you get it, minus minus cancelled. Here utt is 4 is equal to 8 square c square, right? So this implies what is your c square? C square is equal to 4 by 64 is 4 by 16. So what is c? C is 1 by 4 because c is here positive here. So for value of c is equal to 1 by 4, this will satisfy the one dimensional wave equation. Similarly, what is here ut? Ut is equal to c cos ct sin x. Then what is utt? Utt is minus c square sin ct sin x. Then what is here ux? Ux is derivative of sin cos sin ct cos x, and uxx is your sin ct silent. It is cos x is minus sin x. Now you compare this with your one dimensional wave equation. Utt is c square uxx. So that means my left hand side minus c square sin ct sin x, and the right hand side will be my c square into this, means minus sin ct sin x. You see, left hand side is exactly same as the right hand side. So whatever c you choose, so c is any arbitrary positive value, because c is a positive constant variable. Okay, so in that way short questions may be asked. And similarly, if it is asked one question, u is equal to tan inverse y by x, so that satisfy two dimensional Laplace equation. You have to check it that uxx plus uyy is equal to 0. You should check it to solve. Okay. Next come to the applied PDE part, deflection in a vibrating string. Suppose you are given a string of length L. Okay, a string of length L is given to you and it is fixed at both the ends. Right? Suppose in any mean it starts vibrating. Okay, suppose it is fixed at both the ends. Right? It starts vibrating, means there will be a if you allow to vibrate the string, then there will be a vibration like this, there will be some wave like this. Okay, so now assume that the deflection, the vibration at the end point, u at the end point, L point, at any time is here 0, and this deflection at the initial point u0 at time t is equal to here 0, and you apply some initial deflection is here u at, now your initial deflection means at any point at 0 time, right, is equal to your fx, right? That means the objective is to get the subsequent deflection in the string. What is that? The subsequent deflection at any point, at any time, you need to find the subsequent deflection. That means what you have to do, you have to consider the one dimensional wave equation utt is equal to c square uxx. It is one dimensional wave equation. Now what are the conditions here? The condition is the boundary condition u0t is equal to 0 and ult is equal to 0. This is the boundary condition. Then what more conditions you have? Initial deflection fx is equal to ux at time 0, right, is given, and gx is this is initial deflection, and initial velocity is ut differentiate with respect to t at any point at 0 time is my initial velocity. So these are given conditions, right? These are given conditions, and your job is to solve this under these conditions, right? So to solve this, as you know, let u is equal to fx into gy, and you find ut, you find utt, find ux, find uxx, and go on continue in solving. If you simplify it, you will get uxt is equal to the subsequent deflection. You will get the subsequent deflection uxt is equal to summation n is equal to 1 to infinity bn cos lambda n t plus bn star sin lambda n t whole into sin n pi by l x. So this is the subsequent deflection. So we have to know what is bn, what is bn star, right? As if the Fourier coefficient, we have the coefficient here. So what is bn? Bn is equal to 2 by l integral 0 to l fx sin n pi by l x dx. And what is bn star? It is 2 by lambda n l 0 to l gx sin n pi by l x dx. And what is your lambda n? Lambda n is equal to c n pi divided by l. What is c? C is equal to, here c is equal to t by rho root over, or you take c square to make it positive, and here t is the horizontal tension, and your rho is mass per unit length, so unit length. Okay, so now our job is we need to find what is bn, we need to find what is bn star, and lambda n value will find, and we substitute there. This will be my answer. Now the question is, sometimes you are given either one is 0. Suppose fx given g0, then what will happen? If fx is given, you find bn, but bn star will 0 if gx 0. Accordingly, if fx is 0 given, initial deflection is 0, right? Initial deflection is 0 here, then your bn star 0. Here it is initial velocity is 0 here, then here gx is equal to 0. Okay, now let us solve some problems by using this idea. Now coming to one problem, you are given a string of length pi and c square is 1 given. The initial velocity here gx is 0 given, gx is equal to 0 given, and fx is given this. Okay, so you are asked to find the subsequent deflection in the string. So what is uxt? Uxt is equal to summation n is equal to 1 to infinity bn cos lambda n t sin n pi by l x, because bn star is here 0. So now what is bn? Bn is 2 by l 0 to l fx sin n pi by l x dx. So 2 by pi, length of the string is pi, and it is 0 to pi. The value of fx is 0.01 sin 3x into sin nx, because l and pi cancelled, dx. So I have already told you earlier that if this value sin mx into sin nx, if this value are same only, means when n is equal to 3 only, this will give you pi by 2. This will give you pi by 2. Otherwise, when n is not equal to 3, this will give you 0. The rest thing this integral. Okay, this integral. So now it is. So this is equal to your 2 by pi into this, and 0.01 is here. 0.01 is here. Okay. So now here 2 by pi cancelled. So this will give you. Here only B3 is equal to your 0.01. Otherwise here B1, B2, B4 and so on, other things are 0. So you see here, so it is being 3x. We are simply getting this coefficient as the answer. So in case of such trigonometric function, the answer is it is easily seen. Okay, however we have to integrate it. So now what is your lambda n? We have to calculate now. Next we have to calculate what is lambda n. Lambda n is Cn pi by L. C is your 1, n is n, pi by pi. So it is n, but we need lambda 3 because only we have our B3, lambda 3. So what is the answer then? So it is only for B3 it will only exist. Okay. So what is the subsequent deflection? My uxt will be equal to B3 cos lambda 3t sin 3 pi by Lx. So now L is your pi. So what is the value of B3? It is 0.01 cos lambda 3 is my 3 now, lambda n is n, 3t, and L and pi cancelled. It is sin 3x. So this is my answer. Similarly, we may solve one more problem. One more problem is given to you with the same value of c, right? So here fx is equal to this, gx is 0. Gx 0 means here bn star is 0. So now what is bn? You see this is 1 here. So the coefficient will be b1 will be, so for bn it is 2 by L 0 to L fx sin n pi by L x dx. So now if you simplify it, it will give me the b1 is the coefficient, this is my k, and likewise my b this is 2x. So my b2 will be this coefficient, okay, minus k by 2. Okay, so rest all other things here, b3, b4, b5 and everything is 0. Accordingly you find what is uxt. Okay, accordingly you find what is your uxt. Coming to another problem with the same question, c square is equal to 1. With the same question, gx is 0, but fx is given in terms of a signal here. Right, now we have to find fx out of this. Means this fx is splitted in this way. It is from 0 to a, 0 less than x less than a, and from this interval a less than x less than pi. So if I denote it, this coordinate of O is my 0 0. This coordinate of A, say A is my this point is my k here, and this is my B point is my pi 0 here. Okay, so now here within 0 to a, so the fx value is my OA simply, and from here my a to pi, from my a to pi it is simply my AB. Can I not find the equation of the line passing through 2 points? Right, equation of the line passing through 2 points. Suppose here x1 y1 and suppose it is here x2 y2. What is the equation of the line? Y minus y1 is y2 minus y1 by x2 minus x1, x minus x1, right? And y is here fx here. So accordingly I should solve it. If I solve it, I will get it k by ax. fx cos lambda n t sin n pi by Lx, the same way you find this, and finally you substitute what is your uxt. Coming to another problem, you are given c square 1, L is pi, find uxt. Given ux0 is 0. ux0 means it is initial velocity is 0, and initial deflection is 0, and utx0 means initial velocity is given like this. Okay, so here your bn is equal to 0. You find bn star 2 by lambda nl integral 0 to L fx. So accordingly fx sin lambda nt sin n pi by Lx. Okay, so 0 to L you split it 0 to pi by 2 and pi by 2 to pi, and 0 to pi by 2 the function is this, and pi by 2 to pi the function is this. Accordingly you will solve it to get the continue it to get the answer what is uxt. Okay, so here you apply the by parts technique. Already I have explained how to easily evaluate the integral in Fourier series lecture. Okay, you should see the Fourier series, then the basic knowledge of trigonometry and integration, you will get those idea from that. So now in the next applied aspect is the solution of the heat equation, right, by Fourier series to know the subsequent temperature in the bar. So in the previous article we have studied the deflection in a string. Here what we are given, we are given a bar is given, a bar is given, okay, a iron bar or copper bar is given of length L is given to you, right. If you apply some temperature here, the bar is laterally insulated. At any time you apply some temperature to it, at initial time you apply some temperature to it, it is my initial temperature, okay. Now we have some boundary condition. At case 1 we fix this u at 0 point, at u0 t is equal to 0, the temperature at this initial point is 0 and the temperature at the terminal point Lt is equal to 0. This boundary condition is given to you, okay. So there are two cases. So here the case 1 is the end points are kept at 0 degree centigrade, okay, and what is given, that means the boundary condition is u0t is equal to 0 and ult is equal to 0. This is the boundary condition given. Second condition is given ux0, right, initial temperature is here, initial temperature. What you are asked? You are asked to find the subsequent temperature in the bar. What is that? uxt is equal to, so likewise what you will do, solve the one dimensional heat equation, ut is equal to c square uxx, right, under this condition. So how you will solve it? Let u is equal to fx into gt, and you continue in this way, apply the boundary condition, and the solution will be uxt will be equal to summation n is equal to 1 to infinity bn sin n pi by l x e to the power minus lambda n square t, okay. So it is like the Fourier series for half range sine case, and now you need to find what is bn. Here bn is 2 by l integral 0 to l fx sin n pi by l x dx, okay. So now one more thing we have to know, what is lambda n square. What is lambda n? Lambda n is c n pi by l. What is c? C square is equal to k by sigma into rho. What is k? K is the thermal conductivity, and so sigma is the density, rho is the density, and sigma is your specific heat. These are given with proper units, okay. So you find c, you find lambda n, you find bn, and all these things you substitute over here, okay. So let me to solve one problem. Now coming to the problem, you are given, find the temperature uxt in a laterally insulated bar, copper bar. The length is this, L is 80 centimeter, L is 80. If the initial temperature is fx is given this, fx is this, and the ends, this is important, ends are kept at 0 degree centigrade. Once the ends are kept at 0 degree centigrade, it is case 1, ends are kept at 0 degree centigrade, then you have this is the formula, okay. This laterally insulated bar is common in every question, right, and as per the assumption this bar is laterally insulated, the heat is not allowed to evaporate in this way, okay. So now coming to the solution of the and then the next part of the question, how long does it take? First you find uxt here, how long does it take, what is the time required, so that the temperature in the bar will drop down to 50 degrees centigrade. So the formula here is uxt is this and bn is this. Now you substitute the value of fx here, it is 2 by pi 0 to pi, the value of fx is here 100 sin pi x by 80, 100 sin pi x by 80 into sine n pi, L is here 80, x dx. You see, they behave alike here. Okay, it is pi by n pi by 80, it is also n pi by 80. It's not, it is pi by 80. So what is n here? For this is n. For m is equal to n, right? This must be here 1 here, is not it? So for n is equal to 1 here, this is n, this is 1, because you know integral 0 to pi sine mx into sine nx dx is pi by 2 when m is equal to n, 0 m not equal to n. Okay, so this will exist only when this is n equal to 1. So for n is equal to 1, this will give you 2 by pi is there, and this is into this pi by 2, okay, this pi by 2, and this 100 is there, 100 is here, okay, this 100 is here, and when n is not equal to 0, this is your 0, and this is all about your bn. So what is the value of bn? Means you see, you carefully observe, the length is 80 here, and it is pi by 80, right? So it is 1 only, so this b1 is 100. Okay, so by looking into the problem, this type of problem, you will get what is b1. So therefore, what is your b1? b1 is 100 only, and rest other things, your b2, b3, so on are 0. Now let us find what is my lambda n. So now you find this b1 is 100, and similarly if you calculate lambda n, c square is k by sigma into rho. Some more information are given in the question. K, sigma and rho are given like this. Now you substitute k, sigma and rho value, then my c square will be coming this, and lambda n, because only b1 is exist, we have lambda 1, n is equal to 1, value of c square, pi I have taken 3.14, L is 80 given, so you just substitute it, the lambda 1 square value will be this much. So only b1 is exist, so uxt will be this much. So the b1 value is 100 sine pi by 80x e to the power minus 0.001785 t. Okay, so this is the uxt you get. Now it is asked, so for maximum uxt, sine value is 1, so it is only 100 e to the power minus 0.001785 t. Right, now it is given the temperature will drop down to 80 for what time? Okay, so when 50, temperature will drop down to 50 for, it is 100 e to the power, okay, so 50 is equal to this. So now half is equal to my e to the power, suppose I take it minus k, I take it suppose my k, say, okay, k, it is my t, so then it will be so this implies my e to the power minus kt is equal to 0.5. So that means minus kt is equal to my log 0.5. So this implies the value of t will be log 0.5 by minus k. So log minus 0.5, you calculate it. So this value will be minus 0.6931472, and this value will be minus 0. This k value is 00001785. Okay, so now if you simplify it, this value will be here, this value will come in. So if you simplify it, then this will be 388 second, and divided by 60 again, it is coming around 6.5 minutes. So the temperature to drop down to 50 degrees centigrade, how long it will take? It will take 6.5 minutes. Okay, so now coming to one more question. The other question is, suppose instead of initial temperature fx is given like this, and the other data are same, then how long it will take to decrease the same temperature to 50 degrees centigrade? So now since it is 3 pi by 80, so you will get b3 here. So b3 will be 100 you will get. Okay, so accordingly here uxt will be here b3 sine lambda 3t e to the power minus lambda 3 square t. So if you simplify it, b3 is here 100, the value of lambda 3 accordingly you find, it is sine n pi, just a minute, it is sine 3 pi by lx. Okay, it is e to the power this, so it will be here sine 8x sine pi x by 80 e to the power minus lambda 3 square value. Accordingly you get it. Accordingly the lambda 3 square you will be getting this much. Okay, minus of this much. so now the temperature to drop down to 50. So the maximum temperature, this value will give you 1. It is 100 e to the power minus kt say. And likewise, if you simplify, the value of t will be ln 0.5 by minus 0.01607. So it will be around 43 second. Okay, 43 second. So this is the solution to this problem. Likewise, we will solve the problems. Suppose one more problem is L is equal to 10 centimeter, K sigma rho is given like this, and you are asked this. So now this is here 0.01 sine pi x is given. So this will be here. So the correct question is f of x is equal to sine 0.01 pi x, and you are asked to solve it. Okay, so likewise you see here the question is L is equal to 10 sigma rho and K is given. So you are given fx is equal to sine 0.1 pi x. Okay, so what does it mean? It is sine pi by 10 x. You see here L is 10 here. So if you find Bn is 2 by 10 integral 0 to 10 fx sine pi by 10 x into sine n pi by L n pi by 10 x dx. So you see here this value of n, and here what is the value? Here the value is 1. So only b1 will give you here this coefficient will give you b1. Okay, so what is the only you are getting here? b1 you are getting is 1. Okay, only you are getting b1 is equal to 1. And similarly here c square is given. C square is equal to k by sigma into rho, and accordingly lambda n is cn pi by L, but we only need lambda 1. Right? Here lambda 1 value will be lambda 1 square value will come to be. So if you simplify it, your lambda n is cn pi by L. See, you get. So we need lambda 1 here because only b1 is equal to 1 and rest other b2, b3 everything is here 0. So this will be your lambda 1 square will be this much. Okay, it will be this much. Now what is the formula for the subsequent temperature in the string? It is Bn sine n pi by Lx e to the power minus lambda n square t, but here only it is coming B1 sine pi by 10x e to the power minus lambda 1 square t. The value of lambda 1 you substitute over here. So this is B1 is here 1. It is only sine pi by 10x e to the power minus 1.752 pi square by 100 t. So this is your answer. Okay, in this way you will be able to solve it. Suppose one more algebraic problem is given to you. One more question is given to you. Fx is equal to 1 minus 0.2 x minus 5 mod. You know what is your mod x? Mod x is minus x negative plus x positive. Okay, so accordingly we break it. 1 minus 0.2. So where x minus 5 here. So x minus 5 is negative. Means when x less than 5, this will give you minus of x minus 5. And when x minus 5 is positive, means x greater than 5. So this will given here x minus 5. Okay, so accordingly this will be here 1 minus it is 0.2x. It is here minus plus. So if you simplify it, it is here 5 minus x, it is x minus 5. So you multiply it, so it will give you 1 minus 1 cancelled, it will give you 0.2x when x less than 5, it will give you 2 minus 0.2x when x greater than 5, means 5 less than x less than 10, because length is 10 here. Okay, so 0 less than x less than 5. So here bn is equal to 2 by 10, integral 0 to 10 will be splitted in this way, 0 to 5 plus 5 to 10. Okay, f sine n pi by 10x, and accordingly here the value of f will be how much? 0.2 you substitute here, 0.2x, and here this value substitute, and accordingly you solve it. Thereafter you get uxt is equal to summation n is equal to 1 to infinity bn sine n pi by lx e to the power minus lambda n square t, and accordingly you get the answer. So one more last aspect is, so in previous case 1 we have seen that the ends are kept at 0 degree centigrade. Okay, we have seen that the ends are kept at the 0 degree centigrade. Clear? So now if the ends are, in case 1 we have discussed, the ends are kept at 0 degree centigrade. So let me to remind you, in the previous case 1 what we did, ends are kept at 0 degree centigrade, is not it? But here the ends are purely insulated, means you have the adiabatic condition here. So the length is L here, so this u0t becomes ux because it proportional to the gradient here, so it is ux lt. So this is your 0 here, and rest part is fx is same. Fx, the initial temperature at any point at any time, is fx is applied here. Okay, so this is the adiabatic condition, and we have to see what formula is used when the ends are insulated. In previous case it was u0t is equal to ult is equal to 0, means we maintained at 0, but here these ends are purely insulated. Okay, this is the length. So now what is the formula here? So here in this case, okay, you know the rate of flow is proportional to the gradient. Gradient is del u by del x. So as we have kept it insulated purely, so it is ux0t is 0, ux lt is 0, and the initial temperature is given as usual, ux0. Okay, so now we solve this. ut is equal to c square uxx, one dimensional heat equation under this above condition, and we simplify it. Once you simplify it, it will give a formula like half range cosine expansion. Here subsequent temperature will be here, subsequent temperature in bar, it will be a0 plus summation n is equal to 1 to infinity an cos n pi by lx e to the power minus lambda n square t, and then a0, what is a0? A0 is here 1 by L 0 to L fx dx, and an is here 2 by L 0 to L fx cos n pi by L x dx. Okay, and rest here lambda n is same, lambda n is c n pi by L, and c is equal to c square is equal to k by sigma into rho. We write c square, c is positive. Okay, so accordingly if the endpoints are purely insulated, then you apply this technique of formula to solve it. Suppose a problem is given to you, L is equal to pi, c square is equal to 1, ends are perfectly insulated. So out of this we understand that this is the second formula, and fx is given like this. So what is the temperature in the bar? uxt is a0 plus summation n equal to 1 to infinity an cos n pi by lx e to the power minus lambda n square t. So accordingly you find a0 is 1 by pi 0 to pi square minus x square dx. You just simplify it, it is 1 by pi, integrate it, pi square x minus x cube by 3 0 to pi. Okay, and you simplify it accordingly. Here an is 2 by pi 0 to pi square minus x square cos n pi by L nx dx. Okay, so accordingly you apply the by parts formula here. By parts, already I have told you the by parts in my Fourier series lecture. So it is my silent pi square minus x square. The integration of cos nx is sin nx by n, put a negative sign, the derivative is minus 2x, and the integration is minus, put a negative sign, the derivative is minus 2x, integration of sin is minus cos nx by n square, put a positive sign, the derivative is minus 2, and the integration is sin nx by n cube. Okay, and 0 to pi, so 0 to pi, this is here 0, this is here 0, and you just simplify it. Accordingly you find then lambda n you find, right, and finally you substitute what is here uxt. Okay, so likewise you should solve the similar problems, and similarly the Fourier series can also be used for two-dimensional wave equation and two-dimensional heat equation. In subsequent lecture we will see, but the video is getting lengthy, we will close it here, and you should solve the similar problems from any standard book. Okay, so thank you all. Let us close the video here.